a problem that got advertised as tricky on another math channel, and I don't think it was particularly tricky, so I'll see what you guys think. Now, there's two definitions of absolute value. This is an absolute value equation. So if you take a look at the standard two-piece definition, minus 7 is less than 0, right? Minus 7 is certainly less than 0. And it's just easy to think about it as distance, really, from the origin. Now, so according to that, we would use the second piece here. So the absolute value of minus 7, again, this is way too formal. Everybody knows the answer here, but it's minus 7, which certainly equals 7, right? Okay. Again, a little too formal for anybody who knows anything about absolute value. Now, but there's another definition that's more continuous. It's not a piecewise definition, and this is more in line with the, I guess, the Euclidean notion of distance in multiple dimensions. Like if it was x, y, in the plane, distance from the origin would be the square root of x squared plus y squared, just a generalization of Pythagorean's theorem. But anyway, the absolute value of minus 7 under this definition, okay, would certainly equal to minus 7 again. We can write it out if you want to see it. But there's no violations of the domain here. This would be minus 7 quantity squared, which is, of course, 49. Not that you really have to know that. And that's equal to 7. Okay. So the two definitions produce the same results, at least for negative numbers, and they do for positive numbers as well. Now I'm going to use this definition because you guys remember a lot of times you have to, if you're using the two-part definition, you have to, sometimes you get extraneous roots. That doesn't happen when you're using this definition. So let's take a look down here. Now, the first thing I did is just make a raw substitution right here. In other words, the square root of x is equal to the square root of x squared. So literally right here, this piece would be the square root of x squared squared, right? And of course, this piece right here would be 21 times the square root of x squared. Okay, I left the 2 out right there, it looks like. So a 2 belongs there. But folks, so you see, if you just think of it as an object, it factors just like any other thing would factor, okay? The square root of x squared times the square root of x squared is the square root of x squared squared, right? And of course, this is just a direct substitution right here. And you'll notice that this is the combination of numbers 3 minus 24. When you expand this out, it leaves you this coefficient of negative 21, okay? So that's all pretty straightforward. Now we're in pretty good shape here. We are looking for real solutions. We are looking for real valued solutions, not complex solutions here. And so the one that we know is going to give us real valued solutions would be, of course, this factor right here. When we equate this factor to 0, we get x is equal to plus or minus 24. And that's straightforward. Now notice that we did, if you wanted to, you could also, just for the sake of completeness, you could write down the square root of x squared plus 3 equals 0 if you want. But we know that there's no real solutions to that, right? There are no real solutions, no real any solution to this would be complex, right? And so we're not interested in this, no solution, no real solutions. Because you would write down square root of x squared equals negative 3, so we can just write no solution here. No SOL. Okay. Abbreviated, no solution. So, y'all, these are the answers. Plus 24 and minus 24. I liked it a lot. Notice we didn't have to reject extraneous solutions. We just directly used what some people call, I think, the continuous definition of absolute value rather than fumbling around. A problem similar to this was worked at Mind Your Decisions. It was a much easier problem where you could just guess the answers, and I believe the presenter did it piecewise. Ended up with an extraneous solution that he had to check. No checking is required when you do this, when you use this definition of absolute value, because no squaring occurred. We didn't square anything. We just made direct substitutions into this expression, and process the thing in a fashion very similar to just a standard algebra problem. Again, no squaring occurred here, none at all, which is very commonplace when you work absolute value equations. So that's all, folks. This is the solution. Let's see, am I leaving it on the same screen there for you? Yeah. Plus minus 24 is the solution to this equation. Go Argentina.